Okay, let's jump right in. We're taking a deep dive today into this whole area of algebraic expansions and those really handy things called identities.
Right. And expansion, it's basically, multiplying things out, removing the brackets to see what's inside.
Sort of unpacking the expression.
Exactly. But identities, well, that's where the real power lies, I think.
Yeah, how so?
An identity isn't just an equation you solve, it's always true. Like, no matter the values you put in for the variables, think of them as guaranteed shortcuts. Universal truths, really.
Okay, got it. So our mission here is to sort of sift through these sources and pull out the best, the most useful algebraic shortcuts they show us to help you navigate expressions more easily.
Precisely. Making things simpler.
So the sources start with the basics, which is good, refreshing the memory on y plus b22 and ab22.
Absolute fundamentals. A plus B22 gives you $A plus 2AB plus B22.
Right.
And AB22 is almost the same, just A22AB plus B22. That minus sign makes the difference in the middle term.
And what's cool is how the sources immediately show combining these gives you even more shortcuts.
Yes, it's quite elegant if you just add the two expansions together.
The a plus b2 and ab2.
Right. Add them up. Notice the 2 plus 2 appear, the 2
Which to cancel.
They cancel right out, and you're left with A plus B2 plus AB2 plus 2B2, or $2 a plus B2 square.
Huh. Okay, so a direct link between the sum squared, difference squared, and the sum of squares.
And check this out if you subtract them instead.
Yeah.
So A plus B22 minus AB22.
Okay, what happens then?
Well, this time the $2 two terms cancel, and the $2 two terms cancel. But you get $2 2B.
Which is $2 plus 2ab2.
So 4AB.
Exactly. A plus b $2, 4b2, just like that.
That's really neat. And the sources use this, right? They show examples like, if you know what a plus BD is, and you know AB, you don't need AD up separately.
Precisely. You can use these identities to find, say, AB or $2 plus B22 directly. Skips a whole load of steps. They're not just formulas, they're actual problem-solving techniques.
Genuine tools. Okay,
Yeah.
They absolutely are. The sources also mention cubing, A plus B33 and AB33. Similar ideas, a bit more complex.
But then there's this really surprising one the sources point out about 1 would B and C dollars.
Ah, yes. The condition A plus B plus C. This one's fantastic.
So if the three terms add up to 0.
Then the sum of their cubes, $3 plus B3 plus C33, is always just 3BC.
Always. Wow.
Always. It's a fantastic shortcut. Think about calculating something like 3 plus 2 3 plus 3 3. Doing the cubes is effort.
Yeah, a bit tedious.
But wait, $5 plus 2 plus 3 plus $3.
Yeah.
So the identity applies.
Oh, so the answer is just $3 times me. I have a 5 times 2 times 3.
And you got it, which is what, $98 mine, much faster. That 1 plus B plus C dollar condition is key.
That is a huge simplification.
Yeah.
Okay, what else? Squaring 3 terms.
Yeah, they cover A plus B plus C 222. It expands out to $2 plus B2 plus C plus C2 plus 2AB plus 2BC plus 2K.
All the squares plus double all the pairs.
Right. Sum of squares plus twice the sum of products. And this shows another connection. If you happen to know the sum A plus B plus C, and you know the sum of squares, AT2 plus B2 plus C2, you can instantly figure out the sum of the products, AP plus BC plus Keta.
Ah, because they're all related in that one identity.
Exactly. And finally, the sources really drive home how useful these are for simplifying nasty-looking fractions. Using things like the sum or difference of cubes formula, $3 PM B3 to 3, or that more complex one involving $3 plus B3 plus C33 EBC2, lets you cancel terms and just cut through the complexity.
Okay, so wrapping up this deep dive then, algebraic identities. They're more than just equations to memorize.
Definitely. They're like these elegant, reliable relationships that act as powerful shortcuts. They simplify things, show hidden connections.
Making complex expressions much more manageable.
Yeah, they give you efficient ways to solve problems where just grinding through the calculation would be really slow or maybe even obscure the answer. Understanding them really changes your approach.
And just one final thought to leave you with, something the sources brought up that I thought was quite striking. They looked at 1 olig A plus 1A and $1 is A1A. Seems like the 1 and A depend heavily on what A is, right?
You'd think so, yeah.
But remember that identity A plus B2, AB2 equals 4AB?
Yes.
Well, if you let $1 and always, then A B1, so the identity becomes A plus 1A2. A1A2 is 4A1.
Ah, so that's no model name.
Exactly. Tony all at A equals 4, so $5. Always. It doesn't matter what A is, as long as it's not 0. It's just dumped at core.
Wow. That's a perfect example of how identities reveal these simple, constant relationships hidden beneath the surface.
Pretty fascinating stuff.